Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 32 we are going to discuss about question 12.17 of your textual exercise. What we say in that, complete each synthesis by giving missing starting material, reagents or products. Now this question can be asked as a complete the reaction for 4 marks also. Okay, so that we are going to study 12.17. okay, just a minute. Okay, now the first one was what we call it as in your book what was given, ethyl benzene. Now ethyl benzene, when oxidation is carried out and that is KMnO4 is taken in alkyl medium and you heat the mixture, this whole group will be substituted by this CAA group, that is potassium benzoate what we get, right, if you complete this reaction. Then second one, phthalic acid. In that thionyl chloride you use, thionyl chloride, this both H will be substituted by what we call it, OH will be substituted by what, Cl group, what we say, this we already studied in chemical properties, right? So that is what is called phthalic acid converted into thalloyl chloride, what is called, not P, this P is silent. Then benzaldehyde, this is semi-carbazide. What is this? Semi-carbazide. Carbazide will change into carbazone, what we say, that is treating it with this, what we say. Okay, so then next one is benzene plus benzoyl chloride anhydrous AlCl3, means you can see Friedel-Crafts, what we have seen. Now that same concept you can use here, Friedel-Crafts acylation. What is the word? Acylation, right? This is acetyl chloride, what is it? ArCO Cl, what is RCOCl instead of ArCOCl. So benzophenone you will get. What you will get? Benzophenone. Understood? Then the next. So you can see here you get benzaldehyde semi-carbazone. Now here also you can see benzophenone. Now the next one, this one is your Tollens reagent. Which reagent? Tollens reagent, right? So in that you will get carboxylate group, if you remember this one, COO. So 4-oxo, 4-oxo means here 1, this is 2, this is 3 and this 4. So 4-oxo is for this ketone group, what we say. Which group it is? Ketone group. So 4-oxo, just a minute, 4-oxo when we say here in this case, 4-oxo cyclohexane carbaldehyde. So 4-oxocyclohexane carboxylate anion. This is the anion. Anion means a negative ion, right? So this is the one what you get as a product. Then you can see a 2-formyl benzoic acid. The word is what? 2-formyl benzoic acid. So formyl means benzoic acid. This one is taken given preference 1, and then this is 1 and this is 2. This carbon here. 1 and 2. So 2-formyl, that is formaldehyde, what is given there, benzoic acid, NaCl and HCl. In presence of this, what you will get? You will see 2 at second position, that is this is 1 and this is second position 1 hydroxy, that is this carbon is given number 1 and this carbon is given 1 hydroxy means at first position hydroxy cyanomethyl. What is the word given? Cyanomethyl, that is the word. This is for second carbon, this carbon I am talking of, this benzene ring 1 and 2, and this is 1 benzoic acid, right? So at second position this is the substituent, what the name is, 1 hydroxy cyanomethyl. Understood? 1 hydroxy cyanomethyl. You understood this part? Benzoic acid, for this part benzoic acid. Then the next one what is given? Benzaldehyde plus propanol in presence of dilute NaOH. Now when we talk about this, we have already studied which one it is. What it is? Benzaldehyde and propanol. So what will come in this case? We have already discussed. Yes, aldol. So this is your aldol condensation product. What is this? Aldol condensation. When you heat this, there will be a removal of water molecule. So easy way you can remember this thing. This one is your alpha carbon and this is your beta. From beta you remove oxygen and from alpha carbon you remove 2 hydrogen. H2 you remove. So what will happen? This is your alpha. See, all hydrogens are removed from here. right? You can see that, and from here oxygen is removed from here, see, oxygen, so that is being added. So this is your alpha and this is your beta, between that double bond, so 2 methyl 3 phenyl propene 2 enol. This is direct aldol condensation product you want, no? This is the technique what you have to use. Okay, then ethyl 3 oxobutanoate. So in this case ethyl 3 oxo butanoate, what we say. So you can see here, if you want you can see this part, ethyl 3 1 2 and 3 you can see, and sodium borohydride, that is reduction is carried out first and then addition of an acid, you will get what, ethyl 3 hydroxybutanoate, that is ester. So ethyl 3 hydroxybutanoate, understood this part? So 3 hydroxy, when we say, no, here you can write down as this is 1, this is 2 and 4, like this. Understood this part? So this you remember. Then here oxobutanoate, so 1 2 3 and 4. Understood? So third position oxo group, that is the word given here, and butanoate for the ether, what we say, ester, sorry. Then the next one, what is given, cyclohexanol. Cyclohexanol, this is oxidation is carried out in presence of an acid. What you get, cyclohexanon means ketone it will get, alcohol will get converted into ketone. This we have seen in the chemical properties. Okay, now the next one. Now in this 10th one, no, what you can do, no, instead of writing this all complex, no, what we can do, we'll write a direct part, that is methylene cyclohexane when first treated with what we call it as diborane. You can write B2H6 also, or BH3 twice, means B2 and H6 only it will be. First it will treated with what we call it as diborane. Okay, so I'll write here, you can see on that, instead of this whole thing you can write like this, B2 H6, right, and then treating it with H2O2 in presence of an alkali. Understood? So what you will get? You will get this compound. This is your cyclohexyl methanol. Understood? Then PCC means pyridinium chlorochromate you use. You will get what? Cyclohexane carbaldehyde. You will get what? Cyclohexane carbaldehyde. Then the last one, what is given there, cyclohexylidene cyclohexane. This is the word what we say, hexylidene, that is double bond, what we call, and cyclohexane is this. So first it is treated in presence of ozone, then zinc is used as a catalyst, and water. What you will get, cyclohexanone means ketone it will get converted into alkene, what we say, like that, cyclohexylidene, it will get converted into ketone. So this was all about complete the part. Now the next question is give possible explanation for each of the following, that is 18th question. Understood? Now cyclohexanone forms cyanohydrine in good yield, but 2,4,6-trimethyl cyclohexanone does not. Right? So these are the questions. The first one, what is that? The explanation is given for this. You can see cyclohexane when it's treated with HCN, hydrogen cyanide, you will get hexanone cyanohydrine. Well, this one does not give this reaction. This reaction it does not give with HCN. The reason is what? This is because of the presence of the 3-methyl group at alpha position, what we say. Why? Because this carbon when we say, no, so this is your functional group. Next to functional group is alpha. Understood? This is alpha dash and this is alpha. So here if you see there are 2 methyl group at alpha. So the word is what? 2, 3. Total 1, 2 and 3. 3 methyl group at this alpha position with respect to the carbonyl group. Carbonyl means this is the carbonyl group what I am talking about, which hinders the nucleophilic, what you call, attack of CN group, due to which hindrance? Steric hindrance, because these are electron donating group and it will hinder the CN molecule to come at this position to get attached. Understood? However, there is no such steric hindration in cyclohexanone, means here This is cyclohexanon, right? On this side there are simple carbons, what we say, nothing, no any EDG group, electron donating group, or no hindrance will be there. Understood? So this is therefore nucleophilic added by CN occur readily to form cyanohydrin in this case, while it is not possible in this because of this group Ca3. Okay. Then second question, what is the word here? There are two NH2 group in semi-carbazide. However, only one is involved in the formation of semi-carbazone. So that is, this is the important give reason what I am talking about. See, now in this case when we write semi-carbazide has two NH2 group, but one of this which is directly attached to what? Carbonyl carbon is involved in a resonance as shown below. Means you can see here, this is the group which is attached to carbonyl carbon. It will give a resonance structure like this. That is, this is an electron pair, lone pair, which will be given here, because here this C will become plus, because oxygen is more electronegative, it will take the electron pair. So that is being satisfied by this nitrogen and form a double bond. Further resonance structure we write, this is again taken because here is electron deficiency is there, and you will see an oxygen will give the electron pair. So you will see there is a formation of double bond, either on these two sides, what we say, either this side or this side. But main thing happens here, what we say, the reason. As a result of resonance, electron density of NH3 group decreases, and hence it does not act as what? Nucleophile, because first it was acting as a nucleophile, but density decreased, so it will not act as a nucleophile. In contrast, the lone pair of electron on NH2, means this I am talking about, right, of NH2 group that is attached to NH is not involved in what? Resonance, and is therefore what is the word? Available for nucleophilic attend on the C double bond group of the aldehyde and ketone. This is the reason why carbazide has two, but one which is directly attached to this is involved in resonance. That is the reason. What is the question here? There are two NH2 group in semi-carbazone. Now, however, only one is involved in the formation of semi-carbazone. So that is explained through this resonance part, what we say. Okay. Now the third question. See. During the preparation of ester from carboxylic acid and an alcohol in presence of an acid catalyst, the water or the ester should be removed soon as it is formed. The reason why it should be removed, the reaction is given here. The formation of ester from carboxylic acid and alcohol in the presence of acid catalyst is a reversible. This is the important point to be written. It is a reversible reaction, you can see here, right? Therefore, to shift the equilibrium, in which direction? Forward direction, you have to remove this water. The water or the ester form should be removed as fast as is formed. Otherwise, what will happen? Again, it will go in backward direction, because reverse reaction is Lee-Chatelier principle, what we say. And then again, it will get separated into carboxylic acid and alcohol. Why? Because we have already studied here, OH is removed, and from here H, right? Means removal of water molecule is there, what we say. Right? But if this water or this are not separated, again it will react with each other and form what? This carboxylic acid and this one. That is the reason why it should be separated. Okay. Now, question number 19 from your exercise. You can see very nice question and interesting. This we have studied, if you remember, of empirical formula, and from empirical formula, molecular formula we are deriving. Remember that? Okay. So just see this 19 question. An organic compound contains 69.77% carbon and this much hydrogen and rest oxygen. So what do you do? This one you add A, B, and oxygen will C. A plus B plus C will give you 100% of the product, what we say, right? So if you add these two and subtract it from 100, you will get the percentage of oxygen. Now, simple atomic ratio means what we are doing, the percentage divided by atomic mass, what we are doing. So we are getting this. Then the least one, that is 5.88 is multiplied by 1.16, 11.63 multiplied by 1.16, and what is it? 1.16 divided by 1.16, right? So here you will get 1, here you will get 10, and here you will get 5. Approximation what we get. So the empirical formula is C5H10NO, what we say. Now further, the question is very nice. The molecular mass of the compound is given 86. Empirical formula is given. From that mass, if you see, it does not reduce Tollens reagent. If does not reduce Tollens, means it is not aldehyde. But form an addition compound with sodium hydrogen sulfide, that is NaHSO3, and give iodoform test. Okay, so this all we have seen in the test to detect. On vigorous oxidation, it gives ethanoic acid and propanoic acid. Write the possible structure of the compound. So that we are going to discuss next. Okay. Now empirical formula mass means what we got now? That is C, H and O. C5 and H10 and O1 was there, right? So here that mass if you calculate, you will get 86. Molecular mass was also given 86. You divide it, n will be equal to 1. So this formula you multiply with n, that is 1, you will get this same. This is the molecular formula. Now determining the structure of the compound, what we say. See, since the given compound forms sodium hydrogen sulfide addition product, it must be aldehyde or ketone, that we assume it. But the second condition does not reduce Tollens reagent, means therefore it cannot be aldehyde and it must be ketone. So we came into a conclusion, because it does not give Tollens reagent, it cannot be aldehyde, but it must be ketone, what we say. Which one? What we have found out, C5H10O. Now, since the compound give iodoform, therefore the compound must be methyl ketone. That is also confirmed. So you can use this reverse engineering, what we say. See, since the compound on vigorous oxidation give mixture of ethanoic acid and propanoic, therefore the methyl ketone is pentane 2-1. From that we got the conclusion. So here the given structure is this, what we say. Methyl ketone pentane 2-1. Why? Because 1, 2, 3, 4, 5. Methyl ketone or is a pentane 2-1, because second position ketone group is there, right? Now, with NaHCO3, you will see it will give sodium hydrogen sulfide, that is the addition product, right? Now, this on further reaction with iodine and 4NaOH, a iodoform test, what you have seen, it will give iodoform. This is iodoform, right? Sodium butanoate and this. So this all what we have given, the conditions are fulfilling here. Then on vigorous oxidation it gives ethanoic acid and propanoic acid. So our given compound is this, what we say, that is pentane 2-ONE, pentane 2-ONE. Understood this part? Now the last question of this topic, what we say here. Here question is, this is also give reason, can be asked for 2 to 2 marks, what we say. Although phenoxide ion has more number of resonating structure, because we have studied that more resonating structure means more stability. Then carboxylate ion, only one structure. Carboxylic acid is stronger acid than phenol. Give the reason. Okay. So now what is the reason for that? See, the phenoxide ion has more number of resonating structure, but carboxylic acid more stronger acid than phenol, since there are 2 electronegative oxygen. You can see in this carboxylate ion, you can see there are 2 electronegative oxygen of carboxylic acid, what we say, carboxylate ion, 2 electronegative oxygen, while in phenate ion there is only 1 oxygen. One reason, oxygen is more electronegative and there are 2 electronegative oxygens here. Understood? 2 electron atom in carboxylate ion is compared to only 1 oxygen atom in phenate ion. Therefore the electron charge in the carboxylate ion is more dispersed in comparison to phenate ion. Consequently, carboxylate ion is relatively more stable as compared to phenate ion. This one, I am talking about. This carboxylate ion is more stable. Thus, the release of H plus means here if H group is there, the release of this H plus of ion from carboxyl is comparatively, what we call it as, is comparatively easier, and therefore it behaves as stronger acid than phenol. In this case, what happens, we have seen the resonance structure, H, when it is get removed, you will see in the second resonance structure there is a formation of what, double bond O, what we have seen, if you remember, right? And like that it keeps on changing, and you will see more resonance, so the stability will be more, and due to stability the release of H will be what we call more difficult in phenol compared to that of carboxylic acid. That's why carboxylic acid are more stronger acid than phenol. Understood this part? So here we come to an end of this all exercise question. In this part we will go through other question if it is any left out. Just a minute. Okay, now in text question, what we say, 12.4, arrange the following compound in the increasing order of the reactivity nucleophilic addition reaction is the question, right? So here ethanol, propanol, propanone and butanol. So when we say ethanol, 1 CH3 group, here bigger alkyl group, 2 CH3 for propanol and CH3 and ethyl group for butanol when we say. So as we move from ethanol to this and to butanol, the plus I. Plus I means what? Due to EDG, electron donating, this effect of alkyl group increases, and as a result, the positive charge on the carbon, what we say here, on the carbon atom of carbonyl group progressively decreases, and hence attack by what? Nucleophile becomes slower and slower. So here if you see the positive charge you can see on the carbon, that will what? On carbon and carbonyl group progressively what? Decreases, because this one they donate, you can see the arrow here, they donate the electron pair to this carbonyl carbon, and what will happen? The nucleophile to attack on this will be decreasing, because it will not become electron deficient, because they are providing the electron, right? So if you see in this case butanol is the least acidic in this case, then what comes? Sorry, nucleophilic addition, butanol is the least, ethanol is the maximum, because there is only one CH3 group, right? So this is more reactive. What is the word? More reactive. And butanol, when we say ethyl and methyl, bigger groups are there, both two bigger group, what we say? So in this case this is least reactive. What is the word? Least reactive. Understood? Same way the second question is there, benzaldehyde, para-tolualdehyde, then nitro, you can see para-nitrobenzaldehyde and acetophenone, what we say. Understood? So here among the compound, acetophenone is a ketone while all the other are aldehyde. Therefore, acetophenone is least reactive. Understood? One. In para-tolualdehyde, there is a methyl group at the para position. So this is the methyl group at para position, and we know a methyl group is an electron donating group. So which effect we see? Plus I. With respect to the carbonyl, carbonyl means this, which increases electron density or decreases with charge? Positive charge on the carbon of the carbonyl group here, right? It will decrease by hyperconjugation effect. This we have studied in 11th standard, thereby making it less reactive than benzaldehyde. Okay, so this one what we say here. So this is what we call it as, what we say here, methyl group is there on this one, and it will what is the word given? Decreases positive charge on this carbon. You can see the resonance in this case. Okay. On the other hand, in para-benzaldehyde, this is para-benzaldehyde, the nitro group, benzaldehyde, nitro group is an electron withdrawing group. Means this is what? Electron withdrawing group, and it will show which effect? Minus I effect. Understood? Which effect it will show? Minus I effect, what I am talking about. Understood this one? Okay. It withdraws electron both by inductive means minus I, and resonance effect, thereby decreasing electron density on the carbon atom, means here. Understood? Of the carbonyl group, means it will pull all the electron pair towards itself. This facilitates the attack of nucleophile and hence make it more reactive than benzaldehyde. Means here easily a nucleophile can get attack here, so more so the reactivity when we say here, the first one what is para-nitrobenzaldehyde. Okay, because nitro is an electron withdrawing group, so it is more reactive towards nucleophilic addition reaction. More reactive. Understood? Then comes benzaldehyde, and then comes para-tolualdehyde, that is, and then acetophenone is the least, what we call least reactive. Acetophenone. Understood this part? Then in text question 4.5, predict the product of the following reaction. This all are given, that we are going to see the next. Okay, now here you can see predict the reaction, what is given there. Just a minute. Okay. Now this reaction what you seen in hydrazine, hydrazone and all, what we have seen this reaction, our table 12.3 what we have seen. Okay, so this one if get added here, this is the C imine, what is that is cyclopentanone oxime is formed. Understood? This is the reaction. Then here you can see this is phenyl hydrazine, if you remember. So phenyl hydrazine will change into phenyl hydrazone. Understood this part? Directly you can attach this H2 you will remove from here, and this N will get directly attached instead of this oxygen. Okay, and you will get this, that is cyclohexane 2,4. So this is 1, 2, 3 and 4. 2,4 dinitro. If you don't understand, 1, 2, 3 and 4. This is the way you can remember. Okay. Then the next question is this. You can see same thing here. What is that? This is aldehyde. From that, and this is amine, hydrazine. What we say. So here what will happen in this case? There is a removal of water molecule, and you can see this will form imine. C double bond N is there. C double bond N. Understood? This is formed. Then same thing here also. Hydrazine what we have studied about, amine. ethanamine. So here this is COCH3, acetophenone, what we say, in presence of H plus. What you will see, this whole thing will get substituted with this, what we say, from here H2 and from here O is removed, and you will get this compound. Understood this part? Skiff base, what we have studied, if you remember. Skiff. What is the word? Skiff's base. Okay, you can go through that table, it will be easier for you. Then in text question 12.6, give the IUPAC name. So it is simple, 3-phenyl propanoic acid. If you don't understand, what you have to do, you can draw the structure. I will draw the structure here. CH2 and COOH. So 1, 2 and 3. So 3-phenyl at third position, this phenyl group. So 3-phenyl propanoic acid. This one also 1, 2, 3, and here 2 are there, 2. So one will be in the parent chain and another one will be CH3 substituted here. Don't know, I'll write like this: C11CH, COOH. Here one CH3 at this position, another CH3 like this. Understood? So 1, 2, 3, 4. What is the name? 3-methyl. There 3-methyl. What we say? Then butane 2, butane means 4-carbutane, 2-ene, 2-ene, and from that E is removed and OIC acid, butanoic acid. Then in this case 2-methyl cyclopentane carboxylic acid. So this one is your first carbon, this is your second one, 2-methyl cyclopentanoic, pentane carboxylic acid. Then in this case, if you see again here 1, then 2, 3, 4, 5 and 6. So it is 2,4,6 trinitrobenzene. Understood this part? Then in text question number 7, you can see here, show how each of the following compound could be converted to benzoic acid. So this is ethyl benzene. You can see potassium benzoate, what we say, potassium benzoate. Understood? Same thing, KMnO4. This is oxidation is carried out, alkaline KMnO4. Then H3O plus, you will get benzoic acid. Same way acetophenone, same oxidation is carried out, potassium benzoate, you will get benzoic acid after acidification. Or you can also do this reaction also, iodoform reaction. Okay. Then the third one, bromobenzene Mg. This is your AR MgX, that is Grignard reagent. Grignard reagent. Understood? Then dry ice, if you remember, you will get this complex, this H3O plus, and removal of this whole part, what we say, with OH, because H3O plus we get H plus and OH minus, right? Will get substituted, H will get substituted in MgOR, Mg, this one will get removed, so you will get benzoic acid. Okay, now the next one. Okay, now this same phenyl ethene, that is styrene, what we say, it will come in polymer chapter. KMnO4, oxidation, alkaline KMnO4, potassium benzoate, what you get, potassium benzoate. Clear? And this salt, what you get, acid, that is H plus and OH minus, you will get benzoic acid, and here K will be replaced by H, that is methanoic acid. Then which acid of each pair, here you can see, would be accept to be stronger? So here you can see the first one, fluorine, more electronegative. So it is, here you can see it is more, what you call, stronger compared. In second case also fluorine is more, what we say, you can see that acidic strength topic, you will understand. Then in third case also, here fluorine is there, but here in this case this one, this group, because it is nearer to ketone. What is the question reason? Nearer to functional group. If it is nearer to functional group, it will be more, what you call, stronger comparatively. And in this case also you can see two things are given, F3 fluorine, and here only electron donating group this is, and electron, this is electron withdrawing group. Understood? Fluorine when we say CF3. So in this case this will be more stronger. Understood this part? So this we already studied in acidic property. You can go through this. Now if any question is left out, you can just text message me or WhatsApp, that you can do, and we will finish that part. Okay, so we'll stop here. Thank you very much. We come to an end of this chapter. Next time we'll be continuing with a new chapter. Thank you.